Hi guys, welcome to my channel. In this video we are going to solve the questions about the static course, and the question will be to learn how to draw the shear and the moment diagrams. And so before the solving question, please, if you like these videos and if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, and if you want to do if you want me to do something to try to make you understand better for the courses, please comment. I'm going to care and try to make the concepts of this channel better. Okay, so let's solve the question. Now you can see on the screen we have a simply supported beam. Now you can see here, and we have a triangular as a distributed load. And so first I'm going to draw the free body diagram. So draw the free body diagram. For example, this is our beam, and this is roller, and I have just AY, and I have a BY and BX, and I have a 1.5 kilonewton meter as the triangular load, and so I have to convert it to the point load. So how I'm going to do that? So it's going to be something like that: 1.5 multiplied 3 this length and over 2. Okay, so this is going to be equal to 2.25. So 2.25, but it's going to apply at the 2/3 of this beam. Okay, 2/3. So it's going to be at the 2 meter. It's going to be, for example, at this point as 2.25 kilonewton as the force. Now I draw the free body diagram. So let's determine the shear forces. Now first I'm going to take the moment with respect to A minus 1.5 multiplied 3 over 2 and multiplied with 2. Look at here, 1.5 multiplied 3 and over 2 meter, so over 2 because it's a triangular, and multiplied 2 this length. Okay, because I'm taking the moment respect to A. This is 1 meter, this is 2 meter. And plus BY multiplied 3 equal to 0. And from this equation, I'm going to obtain BY equal to 1.5 kilonewton. Okay, and let's determine also for AY. Total FY equal to 0, and 1.5 multiplied 3 over 2 and minus BY. What is BY? 1.5. Okay, so and minus AY equal to 0, and AY equal to 0.75. So for now, just I'm going to show you how the shape of the shear and the moment diagram will be. Okay, then we are going to determine the maximum point of the maximum point of the moment, and then the question will be solved. So, and for example, for this one, I have a shear here. What is the shear at the point A? 0.75, right? 0.75. And look at here, this is the small part. This is the small part. So the force will act as the smallest part from that point. And it's going to increase, and until that point. So it's going to be something like that. Look at here. If you have something straight and you apply the force, and it's going to decrease, but it's going to decrease as a little. Look at here. The force acts as a little, but at this point it acts the 1.5. So it's going to act, for example, this is a line. It's going to act as a little, and then it's going to reach a point, for example, this one. Okay, because at this point you have also, for example, this 0.75, but it's going to decrease with a small slope. Okay, with a small slope. So now I guess you understand how it's going to act, this triangular load. So let's check here. For this one, it's going to be, for example, it's going to act from that point, and it's going to have a slope changes. Okay, but it's going to be a really small. It's not too much. It's going to be small. And this point, yeah, sorry, I'm not good at drawing. This point is going to be 1.5, because look at here at B. At B, I have 1.5 as shear force. So this is point A, and this is the point B. Now I guess you understand how we're going to draw the shear and shear diagram, but I'm just going to find this point where it's changed the heel, okay, where it's changed the heel. So this is going to be, for example, point X, and this is the point 3 minus X. So now if you just make an interpolation and try to find it, you cannot find it. If you try to determine or try to use the triangular method, you cannot find it. So you have to write some equations, okay? So it's going to be like that. I'm going to show you how to write it. Yeah, for example, this is our beam, and we have a force here 1.5, and also we have a point here as it's the point 0, but we have also force here, okay, as gx, for example. It's just a function gx, and we have a distance here x, and this whole distance you can see is 3 meters, right? This whole distance is 3 meters. So it's going to be something like this. I'm going to write an function, and I'm going to obtain the point that I want. So gx equal to x, right? Gx equal to x. For example, this is 1.5 equal to 3 meters. Okay, when I multiply this, gx will be equal to x over 2. Okay, I'm just going to make here like make a multiplication. Okay, it's going to be gx equal to x over 2. So now I can write instead of gx as x over 2. Okay, x over 2. So when I try to find the shear forces, let's take this part or analyze it here. Okay, so I'm going to take this part. This is x over 2, okay, and this is the point x. I have a shear force. What is this shear force at this point? It was 0.75, right? Because this is the point A. 0.75. And I have a shear force here at this direction, V, and I have a moment here at this direction. So, from that shape, how I'm going to take the moment, for example, with respect to A, okay? And then we are going to try to determine the total moment equation, okay? So for this one, let's write first for the shear, okay? So total Fy equal to 0. 1 second, I'm gonna take this part 2 down. For example, it's going to be 0.75 minus, okay? Minus x over 2 multiplied with x, but I'm going to use just point here for the multiplication, okay? X over 2 multiplied x over 2. Why? Because it's a triangular shape. This is a triangular force, okay, for this one. And I have a shear, and plus shear as this shear, okay, this shear. So what is the formulation of this one? What's going to be actually? It's going to be, let's take this to out, and it's going to be x squared over 4, over 4 minus 0.75, and this is going to be equal to the shear force equation, okay? So this is where the point of shear is going to be 0. This is the point of shear that's 0, okay? That is 0. So when I write instead of the shear as 0, and I'm going to obtain the point x. So let's calculate it. For this one, x squared over 4 minus 0.75 equal to 0. And x squared, it's going to be equal to 3. And I'm going to obtain x equal to 1.732. Now I obtain the point x because I'm going to draw the moment diagram here and try to show you how where the maximum moment is, okay? So for example, this is going to increase at this point where the point is the shear is 0, okay? So, for example, this is the maximum, and then it's going to decrease. Sorry, I couldn't draw well, okay? It's going to decrease, and this is the point where the shear is 0. So now I determine, okay, I determine the length of that point, the point of x. Now I determine it. So let's determine the moment equation. Normally, if you take the integration of this, integration of the shear, moment diagram equation, okay? But now I'm going to determine how that equation will be defined. So, okay, so let's find it. From that shape, again, I'm going to determine it. For example, I'm going to take the moment respect to this point, okay? This point is point x. So, total moment at x equal to 0 minus 0.75 multiplied x. Because the length is here, look at it, it's x, okay? And plus x over 2, x over 2 multiplied x. Sorry, I'm going to use the point. 1 second. I don't want you to misunderstand the x here. Multiplied with x, this length, I convert it to the point load, and it's going to apply at the 1/3 of, okay, 1/3 of this x. So 1/3, what does it mean 1/3? It's going to be x over 3, okay? This is this length until that point is going to be 2x over 3, and this will be x over 3. Okay, the moment arm of this force respect to x. So it's going to be x over 3. And also I have a moment at this direction. So, sorry, this direction, sorry, it's going to positive. I forgot to show you, but it's going to be that direction. Plus m equal to 0. Now I obtain it. So what is the formulation of moment? It's going to be 0.75 x minus x cubic over 6. Sorry, no, it's not over 6. It's over 12. Yes, it's over 12. Okay, so it's going to be over 12, I guess. 1 second, I'm going to check. Yes, x over 2 and multiplied x squared over 2 and over 2 because it's a triangular. So it's going to be actually I'm going to have a divide here to 2 because it is a triangular shape. Okay, it's a triangular shape. And the formulation of the equation of the moment also is this one. When I write into this equation, this x equal to 1.732, and the moment when I write this equation, this length into this equation, I'm going to obtain the moment 0.866 as kilonewton meter. Okay. Now I guess you understand how I did it. So this the maximum point where the shear force is 0. Okay, this one for the moment is this one. So this is going to be 0.866 as the maximum moment, which is at the shear force is 0. So now we obtain it. So now I'm going to try to make you understand this part better actually. And for example, I told you that I'm going to take the moment respect to x. Okay, I'm going to take the moment respect to x. I have an x over 2 as the triangular load. Okay, so let's take the moment 0.5. So 0.75 multiply x because you look at here the distance is x. Okay, so 0.75 multiplied x plus, because this is negative, it turns to the clockwise direction, and plus this triangular load, I'm going to convert it to the point load, x over 2 multiplied x. Okay, now I got it. So I have to divide it with 2 because it is a triangular load. So it's going to be something like that: x over 2 multiplied x over 2. Okay, and then multiplied x over 3. Because why x over 3? Because it's a triangular. The center of the triangular is at the 2/3 of that. 2/3, okay? So it's going to be, when we divide the x over 3, and it's going to be 2/3 of that point. From that point, it's going to be x over 3, okay? 1/3, because for example, the centroid of the triangle at the 2/3 So this is 2/3 until that point. Okay, and this is 1/3. So the moment arm will be equal to 1/3. And this one, when you multiply this whole, you are going to obtain x cubic over 12. And the plus m. Why m? Because there is a moment here. Okay, so plus m. It turns to the counterclockwise direction. So I'm going to obtain as the equation of this. I have an x equal to 1.732 because now you can say I determined from the shear. Okay, from the shear equation. So when I applied the x, and so when I write x into its own place, and I'm going to obtain the moment, maximum moment for this shape. So now the question is solved. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please warn me. I'm going to try to make it better. So see you for the next question.